Okay, it looks like our participant list is stabilizing. At this point, I will, I welcome all of you, and I pass you to our leader, Kevin Reed, to give you the background on the seminar series and introduce you to our speakers. Over to you, Kevin.
Awesome. Thanks, Lisa. So yeah, I'll pick us off and just first, I'd like to welcome everybody for taking the time to join the discussion series today. First, I'd like to just give a little bit of a background on the Lighthouse and what we're hoping to learn from this discussion series, which is first, for those of you that know, a few years ago, the WCRP developed new activities, mostly to focus on kind of critical near-term progress towards meeting a lot of the goals outlined not only by the WCRP, but by the broad kind of climate community. And one of these activities they're referred to as lighthouses is the Safe Landing Climate Lighthouse. And this is really focused on an exploration of the routes to safe landing spaces for human and natural systems. And a lot of what the Lighthouse does is explore future pathways that avoid dangerous climate change, while at the same time contributing to United Nations Sustainable Development Goals. Within the Lighthouse, there is a working group that is called the Safe Landing Pathways Working Group, which really focuses on the pathways to these future safe landing climates. And a lot of what we are discussing as part of this working group is thinking about outcomes in terms of what understanding and constraining of individual risks and assigning overall levels of risk to different potential future pathways. And so really looking at pathways a little bit more holistically. And really looking at what are the different types of adaptation and resilience strategies and how do they play a role in ensuring that the pathway is safe. What we're doing here is having our first Safe Landing Climates discussion series. And the idea of the discussion series is mostly for the Safe Landing Climates Lighthouse, as well as the community, to just get a little bit understanding of what's going on in this area and how we can use information to really think about what are the activities of the WCRP in the coming year. And so our first discussion series is focused on desirable scenarios for safe landing climate pathways. It's the first in a series that will continue on and for the rest of the year. So I encourage you to check back or to check your email for the next discussion series to hopefully happen in the next couple of months. But to kick off, what I would like to do, we're going to learn a little bit about scenarios today, climate scenarios, how they're used within the climate community, what are some of the ways in which they can be assessed, and what are some of the ways in which they have challenges related to the use of scenarios by broader communities. And so our first speaker today is Dr. Brian O'Neill. So Brian is a chief scientist and laboratory fellow at the Joint Global Change Research Institute, which is a collaboration between the Pacific Northwest National Laboratory in the United States and the University of Maryland in College Park. And his research interest, as we'll learn about in his overview presentation, focuses on the human-Earth system interactions, and in particular, focusing on the human dimensions of global environmental change. So with that, I will turn it over to you, Brian, to start us off.
Great. Thanks very much, Kevin. Pleasure to be here. Appreciate the invitation. I will share my screen here. And I am going to be talking about scenarios, and in particular, a framework for scenarios called the SSP-RCP framework. It's turned out to be jargon heavy and acronym heavy, so it's sort of fitting that there's just an acronym in the title without it actually being spelled out. What does that mean? What this stands for is the Shared Socioeconomic Pathways, that's SSP, and the Representative Concentration Pathways, that's RCP. These are societal and climate futures respectively, and this framework that it refers to is kind of the ways and approaches for integrating those two things to do interdisciplinary analysis in the future. And I'm going to talk about the status of this framework and the next steps. It's something that was set up Over the past 10 years, its roots go fairly far back, but it's really been in full working order for about the last, I would say, maybe 6 or 7. And let me start, of course, with just what it is, and in the simplest terms possible, how it works. And the idea is represented by this diagram, where you have a number of things situated on this outside circle, a number of elements that are pulled together, intended to be pulled together to do integrated interdisciplinary analysis and scenario development in the middle. Now, those things that get pulled together are the SSPs and RCPs, as we just talked about. SSPs, as I mentioned, are a set of alternative visions of how society globally in large world regions may evolve in the coming decades. The RCPs are greenhouse gas concentration pathways that are used with this orange arrow to produce climate model simulations of the future, so climate futures. These are sometimes combined with policy assumptions, and they are combined with integrated assessment model scenarios of emissions and land use and concentration. So there's all these elements that go into integrated scenarios. So this is a picture of the framework and how it's intended to be used. We often think about it's one thing I want to draw attention to. We often think about, oh, so what are the SSPs and what's in them, what's not in them, what can we learn from them? What we really want to be learning from is not the SSPs per se, but studies that have employed them, because they are an ingredient to integrated scenarios. They are not integrated scenarios themselves. And that's an important distinction that we'll talk more about. But let's, for a minute, go into a little bit more detail about what's in an SSP, and by extension in an integrated scenario that uses them. But the SSPs themselves have 2 components. They have some narrative text, a couple pages of text that tell a story about how the world may evolve, broad patterns of development, the logic of why certain elements are changing in some ways than the others. Why is population declining? Why is the economy perhaps growing especially fast? Why is technological change proceeding in a particular fashion? Relating this to social scientific theories about the way the world works. And then there are a set of quantitative elements that are consistent with those stories about, okay, well, if population is growing at a certain speed, what's the population size in every country over time? The same goes for quantification of levels of education, of urbanization, and of the size of economies. These are done at the country level for the world. And there's 5 of these SSPs, so 5 sets of quantitative elements, 5 narratives. For the sake of time, we won't go into details on exactly what the stories are in each of the 5, but hopefully these titles on the right give you some sense of their content. So these SSPs then are used as input, right, to create other elements of this framework. And one of those elements that, you know, we're all familiar with, pretty familiar with, is the integrated assessment model emission scenarios and land use scenarios that are then used to drive Earth system models. And so these narratives and the quantitative elements and potentially some assumptions about what kind of emissions reduction policies are taking place in the future, these all go into the models and what comes out of the integrated assessment models is these quantifications of emissions and land use change. And this figure I'm showing here is for CO2 emissions. The gray lines are all of the various scenarios that are just collected from the integrated assessment community in general, SSPs, not SSPs, just giving a sense of the range of scenarios that are out there. some with very low emissions, some with very high. The colored lines are a particular set of SSPs, 5 of them combined with a couple that include mitigation policies. And you see that they pretty well span the range of other scenarios that are in the literature. And if we look at these, and you can look at those same scenarios in terms of radiative forcing, just accounting for all of the other gases here. These colored scenarios are the ones that were chosen to drive Earth system models. And that was done most recently in the CMIP-6 exercise, producing a set of ensembles of climate model simulations for quite a number of the SSP-RCP combinations. So how do we combine these things together, the climate model simulations and the socioeconomic simulations or socioeconomic futures? Well, I first want to talk about it kind of conceptually and then give an example or two. So conceptually, right, we want to combine these two things, a number of different forcing pathways or climate model outcomes. These are organized on the x-axis of this square space here. And what's being labeled is the radiative forcing level at the end of the century. Each one of those numbers stands for one of these forcing pathways and climate model outcomes. And then the columns in this space are the different SSPs. So we can combine these two things generally as a matrix of possibilities of possible combinations. Now, this is a little bit of a detail of distinguishing from the 4 RCPs that were in the CMIP-5 exercise. CMIP-6 ran all of those again, but added 3 more to create a set of 7. So each of these white boxes indicates a combination of a particular development pathway with a particular climate outcome. And you see that not all of the combinations have a white box here, and that is because it turned out that some of these weren't feasible combinations. So across the top row, the RCP 8.5, the high forcing scenario, not all of the SSPs, even when there's absolutely no emissions reduction in them, have storylines and quantifications of population and GDP and technological change and emissions and so on. When you do all of that, they don't add up to 8.5 watts per meter squared of warming. Only SSP-5 does in its unmitigated state. And so that's why there's only one box filled in. In some of these, because of or in the SSP-3 scenario in particular, because of the nature of that storyline in particular, that it's a non-cooperative story, without cooperation across countries, you can't reach the low levels of forcing. So there is no boxes down there. But otherwise, if you picked any individual box, like this one I'm highlighting here in green, what that would mean is that would represent sort of a container for all of the studies that investigated what would the world look like, what would impacts be, how much would mitigation cost, how effective would adaptation be if we were in a world that in societal terms evolved according to the SSP-2 storyline, and in climate terms followed the 4.5 watt per meter squared forcing pathway. Now, keeping in mind that SSP-2 can end up following many different forcing pathways. Why? Because of mitigation, right? You're at the top of that SSP-2 column if you do no mitigation. If you do lots of mitigation, you get down to the 1.9 watt per meter squared forcing box, and the 4.5 is with some modest mitigation in between. So studies combine these the climate outcomes and SSP assumptions in an organized way, according to this matrix, to investigate how might outcomes differ if you have conditions or say two different futures in which climate is the same, say according to RCP 4.5, but one follows the SSP2 societal outcome, one follows the SSP3 societal outcome. You're going to have different impacts, different costs of mitigation, and so on. And so that's how you can use this matrix to facilitate work. The SSPs and RCPs have been used quite extensively. So up until about a year ago, there were over 2,000 papers in the literature that use the SSPs, and in many cases, although not all, use RCPs or climate assumptions based on them. And they're used in many different types of studies. The blue boxes here represent, the dark blue boxes represent impact studies. So you see that a little more than half of studies are actually of climate change impacts dominated by agriculture and water. A good number of them are on emissions and emissions reductions, energy, land use, kind of the driver's side. And then there are some others on regional outcomes, methods, and cross-cutting topics. So they're in wide use. They've also been extended beyond these sort of basic elements of narratives and 3 or 4 quantitative elements. Many people have developed additional sets of information consistent with the SSPs to allow them and others to do additional kinds of work. So there are now spatial population projections for all of the SSPs, not just at the national level, but gridded. There's income distributions, not just income growth at the national level, but the distribution of how many people are at lower levels of income versus higher levels of income across countries over time. Same thing for infrastructure, urban land, governance, and so on. There have also been regional versions of the SSPs developed, producing greater detail on the story of what's going on in Europe or at US subregions and so on. As an example, a study developed income distribution projections in order to look at what the implications of climate impacts for poverty were. This example was one done by a couple researchers at the World Bank that used assumptions about demographic change, about education, levels of education changing, and about shifts in employment by sector of the economy over time, particularly people moving from the agriculture sector into manufacturing and services, to look at how income distribution would change in the future when one also accounts for climate change impacts on agriculture and on health, which will also affect their income. This study drew a conclusion that we might end up with more than 100 million additional people being pushed into poverty by 2030 by climate change. The importance of the societal futures to this outcome is illustrated by showing a little bit more detail from that study. Each of these horizontal bars is a number of people that are driven into extreme poverty by climate change. And they're broken down. The top 2 are if we assume a relatively optimistic future societal development pathway, along with just a center, middle of the road climate outcome, right? This is only 2030, so there's not enough time for climate outcomes to diverge by scenario. So in this prosperity or fast economic growth SSP, the number of people driven into poverty is quite low. It's less than 20 million in either the high or low climate change impact scenario. In contrast, if you assume the world evolves according to SSP-4, which is a much more pessimistic scenario, totally separate from climate change, just things are not going well on the poverty front, in that world, climate really hits hard, and you can get, if impacts turn out to be high, over 100 million people in being pushed into poverty. So you see the importance of the SSP as an order of magnitude here for the outcome for impacts of climate on poverty. Okay, I'll stick with just that example because I want to be able to take a few minutes here at the end to talk about where things are going now, or where, let's say, where they need to go, and we'll see where they actually end up going. One is that there is a continuing need to further extend this framework. There's ongoing work on doing better extensions of income distribution, of looking at spatial information beyond population, but also of characteristics of the human population, like their education, their age, their income spatially, to understand spatial vulnerability and where hotspots of vulnerability may be. Also, a lot of push right now to try to connect this framework better to the biodiversity world. It has been used for biodiversity studies, but the connection has not been really strong. And this is really a kind of missed opportunity at the moment that we want to try to take advantage of and make a lot more progress there. It's actually been a while since the SSPs were created, and they are out of date in some respects, in some just base year values. GDPs are different. The outlook for the near term is different. And so with a lot of focus in the climate research world on what's going on over the next 10 or 20 years, it's really important that we update these. I think I'll skip the reference scenario one. More important is maybe thinking, we generated a set of scenarios in these 5 SSPs and lots of mitigation variants of them quite some time ago. Are there scenarios now that shouldn't be in there anymore? So for example, there's been some debate on whether the high scenario, the 8.5 watt per meter squared scenario, is too high. Is it no longer plausible that we could end up with emissions that high? Are there some that are missing? So for example, there's been lots of push in the advocacy community, for example, for a degrowth scenario. And there is no degrowth scenario in the SSPs right now. Is that a gap in our envisioning of the future? Another one I want to emphasize is that the SSPs and the RCPs, right, we can think of these as scenarios of inputs in a sense, right? As I said at the beginning, these are pathways that were developed. They're around the outside circle, right, of elements that we want to combine into integrated scenarios to see how does the world turn out. SSPs are not how the world turns out. They're how the world evolves in the absence of climate change and before we integrate it with the RCPs and the climate outcomes. Do we have community scenarios to share to say, what is an SSP2 4.5, right? The world according to SSP2 and 4.5. What does that world look like? We don't have a common understanding of what that is. We don't have scenarios of the outcomes. And so putting a bunch of effort into those to have a shared understanding of how the world looks like in an integrated sense, I think is a big gap at the moment. And last, I will mention that CMIP6 is over, right? We've done all the climate model simulations for CMIP6. CMIP7 planning is now starting. And so we have to now think over the next 5, 6, 7 years, what kind of climate model simulations do we want to have? What kind of societal futures do we want to use to drive them as part of our CMIP7 exercise, whether that's producing climate futures with full Earth system models or with climate model emulation. So I will end there and turn it back over to Kevin.
Awesome. Thanks, Brian. So I hope that was a good initial talk, and we already have some ideas going for the discussion that will happen towards the end. Let me introduce our next speaker, who is Dr. Anita Engels. So Anita is a social scientist working on climate change, and she has employed economic sociology to analyze the strategic behavior of companies in kind of a world with the challenges of climate change. She has engaged in a variety of interdisciplinary assessment exercises and looked at various ways for possible and plausible future scenarios. And finally, she is a professor of sociology at the University of Hamburg, where she is currently chairing the large research cluster on climate change, and society. So Anita, I will turn it over to you.
Thanks a lot, Kevin. Good evening, good morning, whatever to all of you. I'm very much looking forward to the discussion, and let me share my screen with you. I hope you can now see the presentation mode, right?
Yep.
Okay, great. So I'm very happy that I have the opportunity to talk about this large cluster that Kevin was talking about, and one outcome that we just published. It is a very different approach, I think, compared to the one that you just heard as a presentation, but I think it adds very nicely in a complementary way, so it opens up a great space for discussion later. So what I am going to talk about is the Hamburg Climate Futures Outlook, and it's called Hamburg Outlook because it's produced in Hamburg, but it's not a local outlook, but it's really a global assessment. At least that's our aspiration level, and it's called Climate Futures because we want to look in a combined way about how the climate changes and how society changes with it. It's not a deterministic relationship, but we want to look at the co-evolution of both. And what do we assess? We try to assess the plausibility of specific climate future scenarios. We think it's a very interesting way of asking the question about climate futures. So what I will talk about today in another 8 minutes is how we asked the specific question, what kind of scenario we looked at. So we asked the question about the plausibility of keeping the 1.5 degree limit to global warming. So a very specific climate future, that the Paris climate goals are achieved, that we keep the temperature limit and the emission goals. And we looked in the outlook, we looked at a combination of social drivers and physical processes, but I will stick today with the social drivers. So it's a large group of more than 60 authors who have worked together on this outlook, and it's open access, so you can download it here. So now this is the one climate future scenario that we try to look at. It's, as you see, it's very broad and very generic. It somehow represents a world in which the Paris climate goals have been achieved, and we translate this into the achievement of deep decarbonization by 2050. So in order to stick within the 1.5 degree global warming, we need to achieve somehow on a global level a deep decarbonization. We don't go into technical details what this means, but really a net zero society. We assume that this requires a deep transformational change of society, and of course it's very difficult to foresee or to talk about the plausibility of 40 years to 30 years of change, but we translate that sort of backwards in a scenario which is we look specifically at this decade, because we assume that if we want to achieve deep decarbonization by 2050, due to the long innovation cycles and the infrastructural change that is needed, we need to achieve a lot of the changes in this decade. So that's what we try to look at. How far are we with this change? Can we see that we are moving towards achieving this goal? So how do we assess that, the social plausibility of climate change? We have determined a set of 10 drivers, social drivers, that we think are key for this specific scenario, reaching deep decarbonization by 2050. And so here is, the link a little bit to the societal or socioeconomic pathways, only that it's still very rough, and it's not just one or two sets of drivers, but it looks at a lot of processes in the political world, economic world, social actors, social movements, and so on. So normally when you try to understand how far are we in the process of deep decarbonization, you get a lot of positive signals. For example, you can observe that climate regulation takes place. We have seen in some cases that after COVID-19, the economic recovery programs have really tried to build back better and in a climate-friendly way. We have sometimes very strong social movements pressing for more dramatic climate mitigation policies. We have all kinds of institutional investors who announce their divestment decisions. We have consumers who look for climate-friendly products, and so on. We have corporations announcing all kinds of climate neutrality goals. So you see all this, but what we try to come to is a more realistic assessment of what's really going on and how far we are, other than wishful thinking and really coming up with a positive, with an over-optimistic estimation. So we came to the conclusion, and I'm happy to talk about that in more detail in the discussion, that with all the theoretical background that we assume for the individual drivers, and holding available empirical evidence against these theoretical models of driver change, that as of now, with the changes that we see meeting the 1.5 Paris Agreement temperature goal is not plausible. So some of the drivers support deep decarbonization, but not as quickly and as deeply enough as it would be necessary to really get there. And the driver corporate responses and consumption pattern are even really hindering the change towards deep decarbonization. So I'm skipping part of this, and here is sort of an overview, and you will find this in the Outlook, where we summarize all the results of the individual drivers and also the physical processes that I'm not talking about today. So the last question is, okay, how can we come from this kind of realistic assessment of the plausibility of this desirable future to really supporting desirable futures? How can we identify ways to strengthen this? And we always look at the social drivers and their enabling and constraining conditions. And we also try to show how they work together. And this is one way of thinking about how the interactions between the different social drivers can slowly build up what we call a global opportunity structure, with a densification of instances, repertoires that can be used for strategic action by actors that are trying to promote climate mitigation policies. And then you can see, for example, as of tonight, we had read the news that NGOs file complaints against BNP Paribas, for example, the bank, and they you have a social movement, you have the investors, and you have social movements using the legal climate litigation options to build up cases, and then other drivers can build on that. And so you can have a really densification of all these dynamics building on each other. That's one way of thinking in a positive and constructive way on how actors can use this type of framework to go towards to move closer towards this desirable future that the world achieves the Paris climate agreements. I think that's enough for the discussion, and I'll stop here and hand back to Kevin. Thank you very much.
All right, thank you, Anita. So next we'll move on to our next speaker, which just as a quick reminder, after our next speaker here, we'll have a discussion with all of the panelists. And so be sure to be prepping your questions, and you can already start using them in the question and answer form if you want to put in some ideas already. But our next speaker is Kate Mackenzie, who is an independent consultant and researcher. She's a regular contributor for the Bloomberg Green, as well as an editor of the Polycrisis. Kate has previously held a variety of senior roles in climate finance at various climate-focused think tanks, as well as has worked as for a decade as a financial journalist at the Financial Times in London and Sydney. As part of that, she spent time covering technology, energy, and finance. And she is a non-resident fellow at the Center for Policy Development, which is a nonpartisan think tank. So Kate, I will turn it over to you.
Yeah, so a lot of my work since about 2014 has involved interacting with different audiences and decision makers around climate scenarios. That's never been like, the sole focus of my work, but it's often been kind of quite pivotal, I suppose, to the work I've done, particularly with the financial sector and financial regulators and some other sorts of policymakers as well. Sorry, I'm just coming down with a cold, so I'm a bit sniffly. I think in that time, the understanding of scenarios has changed and evolved quite a bit, but we're still pretty early in the evolution, I think, of understanding and climate scenarios in a really nuanced way, so that they can, the potential of them, I suppose, can be fully realised out in the real world. So I think these will be familiar to a lot of people. Just some examples of the things that I would hear, particularly when the financial sector was first engaging with climate. For many years, we would hear these sorts of problems. But just to sort of, sorry, I'm on the wrong side. Just to summarize, the challenges are often around whether scenarios are meant to be normative versus positive. I think it's often a bit more subtle and nuanced than that. But the context is really important. Lots of people are not paying anywhere near enough attention to the construct and the objectives behind the scenarios to be able to then sort of take the numbers, particularly numeric scenarios like the integrated assessment model pathways that are published through the IPCC cycles, to sort of take them and put them in context. For reference, though, it's there are very similar problems with other sorts of energy transition scenarios in particular. So I've done a lot of work focusing on the International Energy Agency scenarios, and they suffer a similar problem, even though they're kind of, you know, one organization publishing a bunch of a much sort of smaller set of scenarios. These misunderstandings have still been pretty prevalent. And the other thing is that people really grab onto numbers in a really kind of deep way. If you just go to the next slide, please. I'm not sure if I'm there. Oh, that hasn't quite shown up, but hasn't quite manifested properly on the screen. That was an example of when there was kind of a bit of a moment of realization, I think around 2017-18, that that a lot of BECS was appearing in the climate scenarios, despite there not being very much of it actually out in the world, and you know, still something that's pretty limited, but that some of the IAM scenarios were heavily relying on BECS to meet warming goals. And just the next slide. It's a really excellent piece of reporting, by the way. It's from 2017 in Wired magazine. And so the sorts of things that we tend to hear is that, you know, we'll need a lot of CCS specs. Another one was, you know, Asian coal use will grow significantly through 2040. Oil demand will grow until 2030 or beyond. Those are just a few examples of the kinds of things that are often, you know, asserted as fact, and on the basis of numbers that are in scenarios. So thanks, Narelle. If you could just go to the next slide. Sorry, this is an old version. You could just skip through. Yeah, sorry, just to that one. That one's great. Thank you. So this is, I think everyone will recognise the illustrated pathways from the 1.5 special report. I think this was a really good, clear example of a scenario, of using scenarios in ways that non-expert users could understand them and could actually get a bit of a sense of what the objective was, and that there were trade-offs, for example, between different energy sources, and between the amount of fossil fuel mitigation, versus the amount of net CDR that would have to be affected to offset or counteract that to meet the 1.5 limit, or stay within the 1.5 warming limit. I think and I remember getting comments from people, you know, people working in the financial sector, that they found this sort of thing very useful, particularly below the little list of numbers that appears below this, that gives some ideas of the shifts in different energy sources and mitigation sources over the coming decades. I think one area where this type of layout and concept didn't work so well was that it sort of gave the sense that these were all equivalent choices. It maybe didn't convey to all of those audiences that you know, some of these negative emissions options, P3 and P4, are obviously like far more challenging than others, and you know, create a whole bunch of difficulties. Thanks, Narelle. Okay, I think I'll just skip through these next two pretty quickly. They're just a couple of examples, again, from SR 1.5 that I thought were interesting. It's probably a little bit along the lines of what Anita just presented, where they're more sort of qualitative, sort of less numeric, and looking a bit more. I think what I liked about these examples, though, were that they were particularly looking at the trade-offs, and that's often a real, that's often, you know, really important thing that you want to convey, is that there are the trade-offs, and, you know, to some extent also ideally the synergies between different mitigation pathways. If you could skip to the next one. So I'll just talk about a few issues that are becoming really prevalent, that perhaps further scenario development, the type of thing that Brian was talking about, and also the type of work that Anita is working on as well, could be helpful in addressing. Some of the emerging issues, I think everyone's probably really aware that there's been a lot of interest and attention on the role of transition minerals and in mitigating climate change, or in the energy transition in particular. This has been really quite interesting, I think, for a lot of us to see that something that perhaps didn't have a lot of attention in a lot of the scenarios has now become, you know, seemingly this like really big issue, and there's a real appetite to discuss this, like a very big appetite to discuss this, and to also kind of, I think in a lot of cases, to frame it as like a real barrier to transition. There are some newer pieces of work looking at the role of transition minerals, but not heaps, as far as I'm aware. And it's something where the demand side of the equation is very important. You know, there's a lot of variables on the demand side around technology processes, consumption patterns, infrastructure, and also to an extent things like recycling. If you just want to go to the next slide, please. This is a point about, this is more relates to the Earth system model. So I think it's not directly relevant to scenarios in a sense, although it's something to kind of be aware of, I suppose, is that a kind of a little industry of selling financial climate impact analytics has emerged in the last sort of 4 years or so. And this is a screenshot of a piece of work done by Moody's, for example, which acquired a company about 3 years ago called 427, who developed these services. So there's sometimes a bit of crossover, I think, between this work. It tends to be more bottom up, and like I said, more referring to Earth systems models. But yeah, it's an area of interest. And the next slide, please. The use of carbon pricing, carbon price as a proxy, I think, for a lot of other policy measures. But that's, you know, I think that's always been understood by the modelling community and the scenario development community, that the carbon price is just depicting, you know, other ways of potentially other policy mitigation tools. But it's often come across as like the carbon price needs to be at this level, you know, an actual carbon price needs to be at this level. So it's becoming harder to get that, to, I guess, get like policy measures across when you're just referring to a carbon price. I think it's important to kind of be more nuanced. I know there's sort of pieces of work that unpack different policy prescriptions, or sorry, different policy tools. So it's that can be useful. And the next slide, please. Something else that's happened in the last sort of 1 to 2 years is inflation. Obviously, has become like really prevalent. I'm not aware of this being considered very deeply in many of the climate scenarios that I've seen from of different types. But there's some emerging work around the systemically significant sectors and parts of the economy, because a lot of the inflation that we've seen has been supply side. It's very challenging for monetary policy, so you know, official interest rates and the like to address supply side inflation, and supply side factors are also really can be very much affected by climate change, by the impacts of climate change, and can lead to, you know, various sort of feedbacks in terms of the political feasibility of mitigation measures. It's something to, I think that could be really relevant and will probably be increasingly relevant over the coming years is the use, the sort of the necessity of certain elements of economies. So what this research is showing, this is by Isabella Weber and a few colleagues, just came out in December. But what it's showing is that, interestingly, the oil and gas extraction, so upstream oil and gas sector, has a really big indirect effect on inflation. And one of the conclusions that the authors drew from this analysis is that it's going to be very hard to transition seamlessly from one energy system to another, that you know, have to kind of overbuild the new energy system first before switching off the old one. So it's something else that I think is not always depicted in a lot of sort of texture in scenarios and pathways. So I think.
So Kate, I just wanted to just chime in and say you have about a minute left.
Yeah, no, I think I'm just going to leave it there. There's Neroli, you just want to skip 2 slides ahead. That one's just sort of a list of the thing though. But yeah, just a couple of points just to make them safer, make scenarios safer, as the theme of this work program, is just to kind of encourage everyone involved in developing scenarios to be a lot more upfront in communicating your assumptions and the objectives, just far more than you'd think. It's a lot harder to get those things across than you might expect, and much more important. Thank you. Leave it there.
All right, thank you, Kate. So now we're going to move over to the panel discussion, in which we'll open it up to everybody that's viewing to ask some questions in the Q&A. But to do that, I want to just introduce really quick Dr. Lisa Miller, who is going to moderate the panel discussion. So let me introduce Lisa real quick. So Lisa is a scientist at the Fisheries and Oceans Canada, and part of the, I believe, Institute of Ocean Sciences, if I remember. And Lisa is a climate geochemist who is interested in the roles that the ocean plays in planetary evolution and global change. So Lisa, I'm going to turn it over to you to moderate the discussion.
Okay, super. Thanks a lot, Kevin. And thank you, Kate, Anita, and Brian, for getting us off to a very good start here. I think you've provided us with a lot of information and context. I certainly have learned a lot from all this. So I want to encourage all of our participants and listeners to enter any questions you might have into the Q&A field. If you put them in the chat field, you will get a nasty message from Narelle telling you to move it to the Q&A field. And also you have opportunity to up and down vote other people's questions. And that will help me decide which ones are most important. But while we're waiting for questions to come in from our at-home audience, I will start out with a question for our 3 panelists. Gonzalo, do we have them all spotlighted? Can we get them all on the screen? The first question I want to ask you folks are going down to the fundamental founding goals of the WCRP Safe Landing Climate's Lighthouse. I want to ask the 3 of you, do you have a view on what a safe landing pathway would look like in your experience working with scenarios? And what do you as developers, users, and communicators of scenarios think is most important to include in scenario development? And it doesn't matter to me which of you starts. If one of you has an idea, want to go ahead and start? Anyone?
Sure, I can jump in.
Great.
Well, you won't be surprised to hear me say that I think these need to integrate a number of things, and a couple broad areas I would just throw out there. I think when you hear safe landing pathway, you might naturally first think about climate change impacts, and how do we keep ourselves safe from those consequences. I would say, and that's good and important, I would say two other things that this would need to consider is the impacts of mitigation, emissions reduction activities themselves, because those also pose a lot of risks, especially if our safe landing pathway is one that's going to involve, really rapid transitions to a net zero world. Those are very, very big systemic changes. And in a world that doesn't really run super smoothly all the time, those are also unlikely to go smoothly. And so really paying attention in these pathways to what society is doing on the mitigation side. And finally, and this potentially makes the scope a little too large for this lighthouse activity, which is fair enough. But for a complete picture of what we mean by safe, for a lot of outcomes that are, particularly those that are measures of human well-being, so things like the poverty example I showed, for example, right? Most of the poverty outcome anticipated in the coming decades is not due to climate change. It's due to many other non-climate related factors. Climate actually has a fairly small projected impact. It's 100 million in 2030. That sounds like a big number, but that's in the context of poverty falling by, several 100 million due to other non-climate factors. So if we really wanted to be judging safety of a whole pathway, we'd have to be accounting for kind of development related factors at the same time that we were looking at climate impacts and mitigation activities. So it's a tall order.
We got a big job to do. Anita and Kate, do you want to add anything to that?
Actually, I wasn't quite sure whether your question aims at the way how we deal with the scenarios, how we construct them, or with the processes that we try to analyze in the real world. The safe landing, how can I imagine that? It has two completely different answers to that. The way we try to construct scenarios, the climate futures that we look at, you have seen, is very, very broad, not very technical, very generic. And I think the safe, the term safe, creates an idea how to get to this climate future that is not necessarily linear, but it's in one direction. And if I look realistically at what I really see out there in social processes, it's always an up and down. So sometimes we have a really strong drive, in climate mitigation, and then the next day something happens and you see it's, all over again, the same old story. So I often, when we discuss about how we think about the climate futures and these drivers pushing the social world towards or away from this future, with my colleagues in the natural sciences, I feel this strong urge that a safe way also means really a stabilizing way, that society, social processes are once and for good channeled in a specific way. But what we see in the real world, it's it's always turmoil, always something new. In the very few years that we have been doing this exercise, we had changes in the US government, we had a pandemic, we had a war. And so, that's my impression on how we talk about safe landing. It's also the way towards a specific scenario.
Right, yeah. So the question is how can this stuff be incorporated and included in scenarios, I think. Kate, did you want to add anything?
Yeah, I don't know. Look, I think it's very difficult to do and very challenging. I think I think events of the last few years and some of the work that's being undertaken now just illustrates that it's such a big task. It's such a big set of things that need to be done that interact with so many other aspects of of world society, economics, development, so forth. Sorry about the background noise. That it's quite it's just really, I think things are going to keep emerging that we haven't anticipated, which is, I think what's interesting about about Anita's work, but also, a really important part of the integrated models work as well, is just to be able to kind of be fairly nimble. I think broadly, like the political, including the sort of political feasibility and the like, for want of a better word, the kind of like the justice and equity implications is really probably critical as well. And that's, it's complex. I know modeling adaptation, having adaptation included very explicitly in scenarios is really challenging, and that would, obviously doing that better would be pretty essential to make it safer. But again, these are this
issue of being able to build nimbleness in is striking me as really important and really hard. So we do have a question from the audience, and it's quite a good one. So I'll read it to you. I assume the three of you can also see it, but just as the question is from Peter Raymond, and what is the real world understanding of climate scenarios and climatic tipping points, as there are not square waves or disruptions in the RCPs or SSP narratives that reflect this? So we've touched on tipping points question a bit, but do any of the three of you want to say anything about that? Kate, that's sort of that. It's back to that realistic, and how do you make people understand? Question.
Yeah, that's that is a good question. Yeah, I think this is actually, I had somebody in the financial sector asking me about this last week and saying, aren't we? Actually, I think she was referring also to the specific scenarios that have been created for the financial sector by regulators. So the central bank, there's a sort of a international central bank group, for example, that are developing climate scenarios for the financial world. But so the question was, is this all too smooth? Are we not really seeing tipping points? Are we just kind of coming out with some very sort of comforting, I guess, comforting and kind of smooth kind of transition pathways, and not really anticipating some of the really disruptive points. So I don't know. I think that the real world appetite is probably very strong, and the and the ability to kind of incorporate these is robustly and nimbly is the challenge. Yeah.
Thank you. Anita, Brian, do you want to add anything?
I think I would like to answer to the next question.
You want to tackle Peter Alexander's question? Go for it.
Yeah, thanks a lot for this question. I mean, we have tried to build up this framework for the social plausibility assessment with the 10 drivers that we think are most important for deep decarbonization. And then, as you say, sometimes happens, it can be a disruptive shock. and then it's easy to assume, yeah, but afterwards, you know, we'll get over this, even if it's 2 or 3 years of pandemic, and we have seen this with the emissions, you know, the emission levels. We have gone back to normal level immediately, but there are. And each time we have such a disruptive event, like the war, Russia against Ukraine, then we try to check with all of the drivers what is going on as a response. How is this disruptive event changing the direction of these drivers? And for example, if you look at UN climate governance, the political situation in the world might actually change for a very long time and in a deep way if what happens now as a consequence of Ukraine is a severe weakening of the multilateral state of the world, then the prospects of really effective agreements is very low. And so this really changes the state of the social world for a long time. But on other examples, you are quite right that you know, there are ups and downs, and it takes a more you know, long-term perspective to really get a realistic understanding of where these drivers are going to. And I think we should try to incorporate such events in the scenarios and try to understand which one is really a game changer. And I'm always very, very careful with assuming that something is a complete game changer, because we have had this so often in the past. And then when we come back to that same event, you know, with a distance from 5 years or so, we see, yeah, you know, everything is back on track in the old way. So it's a really fascinating question, how to respond to that, in how to build the scenario and think about the drivers and to analyze them.
Excellent. Yes. Yeah, intimidating. Brian, did you want to add anything more before we move on from these two questions?
I do, because I think that it's worthwhile to design scenarios to investigate particular, whether it's tipping points as the previous question, or it could be war, pandemic, particular event. If you're interested in how the world, how such a thing might occur and how the world might respond to it. If you're interested more in how such events in general might affect longer term outcomes, well, I would say the approach in the SSPs is not to ignore these kinds of, I would call them extreme events, right? Sort of extreme social events. They're not ignored, right? After all, like SSP-3 is a regional rivalry, a conflict scenario where it's assumed there are wars, there are conflicts going on. Now, that we did not translate that into saying, well, and in this scenario, this country will fight that country in this particular year, and this is how many people will die, and so on, right? So there aren't individual events specified, but there are types of events that are assumed to be occurring that are part of the explanation for why GDP is growing in a certain way, why fertility is not falling as fast, or mortality is higher, or other kinds of assumptions like this. There was a piece in Science, a news piece a while back, that I think did this very well in talking about the pandemic, right? Because the question, you can say, oh, well, the SSPs don't have the pandemic in them. I guess we need to throw them all out, because the world is already different than in any SSP. And again, right? Yes, there is no pandemic, but there are assumed to be events that influence the world to take one path or another that differ very widely. SSP-1 is extremely different from SSP-3 or SSP-4. Somehow in SSP-1, the world in general kind of devotes itself to sustainable development, right? Everywhere. There's a massive change in social understanding and priorities, and somehow that happens. And in SSP-3, things kind of fall apart into regional factions, and somehow that happens. It's possible that a pandemic and our response to it is part of that change, right? We may look back 30 years from now and say, you know, we got to where we are today in this world, which happens to look like a lot like one of these SSPs. When that pandemic occurred, we started down this pathway. It led to other kinds of societal changes, which led to other things and so on. So I would say that it's not the case that scenarios don't include these kinds of things. It is the case they don't include them explicitly. And it is valuable probably for some kinds of analysis to actually do that, to include them explicitly. So I would say great for doing that, but not because we don't consider them at all at the moment.
That was definitely clarifying for me. Yeah, thank you, Brian. We got another question that's specifically, if you're not tired of talking yet, directed to you. But I expect that Kate and Anita may also have insights into it. We've got a question asking about this degrowth scenario that you suggested might be needed. The question is, could you sketch out how this would roughly look from your perspective, as the literature on the degrowth topic is rather diverse beyond the basis of increasing resource efficiency and reducing excess demand? Mm-hmm. Do you think it could be mainstreamed as much as the other SSPs have been? And well, yeah, as I said, I expect both Anita and Kate will also have things to say about that.
Mm-hmm. Yeah, there's been a lot of discussion in various areas about this. And yeah, it's true. I'm not really up on all of the full diversity of types of degrowth scenarios of what people are talking about. I think the milder version is a plateauing of growth in terms of economic growth in developed countries, or when countries reach a certain level of development. So it's not necessarily absolute decline in standards of living, and it's certainly not declining or slowing down developing country trends. But I think there are other versions of it which are stronger. And so I would guess if something were added to the SSP framework, it might be one of the former and maybe not one of the stronger versions. And whether it became mainstreamed, I think at this point for SSPs, a lot of it depends on simply the community and who jumps in to develop something, and then more importantly, who uses it. Because it will be mainstreamed if lots of people want to use that scenario, and there's a real need for scientific analysis that would benefit from using a degrowth scenario, or some kind of limited or degrowth scenario. Then it will be mainstream, just de facto. And there's a lot of stuff in the SSPs like that right now, right? Like the spatial population projections, the income distribution projections, and so on. There's no official body that stamps them. These are SSP official projections. But if so many people use them, they just sort of become that way. And that's the way a lot of this works at the moment.
Okay, that's, yeah, interesting. Kate, Anita, do you want to add anything? I'd like to explore this question of nimbleness a little more, but go ahead first, Kate.
Can I just ask, Brian, what's your sense of what drives that that interest and that focus from the research community? Because that's an interesting sort of process that you've described there. Like what, you know, why are some, sorry about the noise again. Yeah, what have you observed any like factors that particularly drive it, or like drive sort of excitement in the research community about particular scenarios or pathways or SSPs?
For degrowth pathways in particular, or just in general?
I suppose yeah, I think more in general, because I think there seems to be like a sense of excitement around certain things sometimes, like the, you know, you referred to the RCP 8.5, you know, whether that's very useful anymore. And, you know, I remember seeing this emerging as a whole kind of, really it emerged as a whole thing on Twitter, as far as I could tell, and then kind of filtered back to the research community. I don't know, I might be wrong, but it was very, very interesting. You know, what was driving that, I suppose.
Yeah, I think there can be a number of different things. There can be a sort of path dependency, in that some things get used for something initially, like the illustrative pathways that you showed. The ones that were done for the 6th assessment report that came out recently for the mitigation report has another set of illustrative pathways, most of them based on SSP-2. So then a lot of mitigation studies get based on SSP-2 because they want to compare to the illustrative pathways that were in the IPCC report. And then you get this, you know, sort of feedback effect, is that you get a whole bunch of studies, mitigation studies, that use SSP-2. In other cases, like the 8.5, it was an issue became highlighted, which was really in the end a communications issue, I think. I mean, it's a substantive one now. The world has changed. I mean, if you make scenarios that had a base year like 2010, and then more than a decade goes by, it's likely that outlooks will have changed. And so keeping up and saying, well, you know, at that time we hadn't had a really steep decline in renewable prices, and so a coal-heavy world seemed plausible. Now maybe it seems less plausible. That's natural to be expected. I think the RCP 8.5 thing initially got started with a communication problem, in that it became misinterpreted as the most likely outcome if nothing was done about climate change. And that was never the case from the beginning. But there was some wording choices around business as usual that weren't really good at the beginning. And, you know, I think really through no fault of anyone's, but it became misinterpreted. And that had consequences, and it was worth pointing it out. So I think in the end, that was a net benefit to sort of hopefully correct the way the scenario is interpreted and described. And I think there will be some larger assessment of high scenarios in general, the sort of how high is too high question, which really hasn't, there hasn't been a study that's really focused on that yet.
Yeah, that's good to know. You see that shift in the attitude towards the 8.5 happening. It still feels like a lot of people are just assuming that that's where we're heading, and you know, a lot of research will only look at the impacts of that one and not the intermediate ones. But I'm glad to hear that shift, you're seeing that shift starting to happen. Anita, do you want to say anything about the degrowth?
Yeah, I'd like to come back to the specific degrowth idea. My observation is that it becomes more and more, not yet mainstream, but really groups and communities are trying to think about it and to describe what it might mean, that have been completely out of touch with such kind of topic only a few years ago. I mean, degrowth was a very, very specific idea in a marginalized.
It was a fringe sort of wacky thing,
And so now it's really interesting to see that grow, and my interpretation is that people start to realize that there is really this just huge gap between, you know, this curve of the emissions going down that we need to see at some point, and the real one, you know, that's just, it's completely disconnected, and the you know, the longer we wait, the more problematic it becomes. And I think it's one way of reacting to that, to find ways how could at some point could we imagine the emissions going down. It's not, if you asked me, it's not a very plausible scenario at the moment, but I like very much that it is discussed, because it opens up you know, creative thinking.
And creative thinking is what we need. So we're down to, we have just 5 minutes left. And with that, I would like to turn to a theme that has continued, I've been continually hearing coming up, is the question of nimbleness and flexibility in the scenarios. And so I want to wrap up by asking all three of you, how could scenarios be developed to be more nimble, to better represent tipping points, for example, both and other kinds of rapid transitions, as well as extreme events, and both positive and negative? Do we just need to have a whole lot more people working on scenario development, or is there, you can just, how can we make them more nimble and less static, and at the same, and part of that also is people to understand that these are not fixed true things. The communication and misunderstanding problem. So maybe there isn't an answer, but what ideas you have? Anita, go ahead.
Yeah, I mean, the way we deal with these changes is that we do the outcome and the plausibility assessment recurrently. We try to do it every year, and so we already assume, you know, that we will come to a new result. We hope not, of course, that for example, if we ask again and again, how plausible is it that we achieve deep decarbonization fast enough, that we were so wrong with our pessimistic assessment. Yeah? But it's we don't have the pressure to feed our drivers, our models, and our scenario thinking directly into a quantitative formalized model. So that frees us very conveniently from this necessity that you know, to create something stable that we can use for large-scale climate simulations. We have them as well, but it's a different exercise that we do with a social plausibility assessment, and we try to always bring it together, but it's not closely coupled into one you know, computer-based large-scale climate scenario. So that gives us a little bit more leeway to think about and to always include new changes.
So is it safe to say that the IPCC and CMIT cycles and the inflexibility in those cycles is actually really hobbling us in using scenarios effectively? Okay,
I mean,
I saw that.
they are very strong. I wouldn't, you know, play them out against each other. So I think we need a greater diversity of how we work with future scenarios. That was my point.
Yeah, I would agree with that. I think that there's a role for the IPCC and CMIP cycles, and they're not things you would want to do, every year. But there's a lot of things that you kind of by definition make sort of not feasible to do it with these large scale, many people involved scenarios that you want to have be usable for many years into the future. That excludes, well, nimbleness in a way. Like you can't sort of look at really individual topics very easily, because then they become quite idiosyncratic and not widely applicable. So I think if we had a greater ecosystem, bigger and more diverse, of developing different kinds of scenarios and more places doing the kinds of work that Anita talked about, a lot more could get tackled.
All right, so we need to recruit more grad students.
That's right.
Yeah. Kate, we're down at 30 after the hour, but did you have any final comments you wanted to make?
No, I think I just really agree with the last couple of comments by Brian and Anita, that we are starting to see a bit more of a kind of a proliferation of the scenario approach, and both the sort of non-quantitative, non-modeled approaches that Anita's doing, but also some like sort of smaller and nimbler ones. Like when I looked at transition minerals, I don't know, a year ago, there were very few scenarios looking specifically at them, that were looking at different supply and demand pathways. And there was a new one published just a month ago that was quite interesting, just looking at US transport. And, it'd be good to, I think this kind of along the lines of what Brian was just saying, it's good to see more, different approaches to mapping out scenarios. So yeah, so people will get more, end users and the public will also are becoming more familiar with what they mean and what they're showing and not showing, that they're actually kind of mapping out possible futures, not prescribing and not sort of preordaining an actual future.
Right. Excellent, super. And so on that note, I want to thank all three of you for excellent, really stimulating conversation. I've definitely learned a lot today, and I want to thank all of our participants and the people who asked questions. Kevin can correct me, but the plan is detailed notes have been taken of this, and all of this discussion is going to feed into the development of the Safe Landing Lighthouse, and as we go forward with this. And Kevin, did you want to say any closing words?
No, just thank you to everybody that participated, and keep an eye out for a future discussion series on safe landing climates. And also just a quick reminder that the Open Science Conference for the WCRP, that abstracts are due within a few weeks, and there is a poster cluster related to the topic that we just discussed today. So please look for it.
Yeah, thank you. Good. I'm glad I called him in. And our hosts in Geneva are actually, it's very late at night for them. So with that, I will thank everyone one more time, applaud our panelists, and say good night to those of you in Europe, and have a good day to those of you in Australia and Eastern Asia. And good afternoon to the North Americans.
Thanks a lot for having me. Bye.
Thanks very much. Bye-bye.